Hi everyone, my name is Kristen Satch and I work at WSB. Today we'll be hearing from Tom Walker, one of WSB's GIS specialists. He will be introducing WSB's new innovations with reality capture, interior scanning, exterior scanning, and manhole scanning. All right, Tom, I'll take it away.
Thanks, Kristen. Hi, everyone. Like Kristen said, I'm a GIS specialist here at WSB. I've been here for 3 years now, and I was fortunately tasked with this cool new technology to kind of advance it further for WSB. So reality capture, and we'll move forward here. The reality capture, this is a bit of a description, but it is a blanket term, I like to say. So there's a lot that can fit under the reality capture umbrella. What I'll be discussing today mainly is interior and ground scanning and how we can use that, but drones would definitely be another one that would kind of be under the umbrella of reality capture. And I'm sure there will be a webinar down the line that WSB does for those. So what reality capture is, and as it says in the name, is you're literally capturing reality in a set time. And so where this really comes in handy, and we'll discuss this a little further, is if you want to see how a building is at this current time, or how the surface of the ground is at this current time, that may change, but you need to plan on it as it is in that set time. That's where reality capture really comes in handy, is we can capture the time and then we can plan based on what we captured digitally, and that saves a lot of time and money. So there's many types of scanners. The scanners that I have shown here are what WSB currently uses for reality capture. And I like to lay it out this way, 1, 2, and 3, because of the price ranges, right? So, and I'll explain quickly what you get different with these price ranges. So the first scanner that I have here is a pretty basic scanner. It's going to be on the lower price range. What you get with this is a very high resolution imagery. So this is going to be more so used for the maybe public engagement, or just because you need to see little writing on something. This is going to be the scanner you're going to want to use. You do get the same output as the other scanners. It's just the accuracy isn't going to be there for a lot of planning purposes, and we'll show what the output looks like of that. The second scanner, I put it in the middle because that's exactly what it is in terms of price. It's right in the middle of these two scanners. You're going to get way more accuracy than you're going to get with the first scanner that we showed there. But the difference between 2 and 3, other than price, is 3 comes with the geolocation of these point clouds that we're going to be talking about here shortly. So you're going to actually get a location in the earth where these point clouds were shot, and that comes in handy with especially surfaces on the engineering side when we're planning on putting a building on a surface, and we want to scan the surface and see how that changes over time. You're going to want to actually put that for planning purposes in a coordinate system. So that's going to be the difference between these scanners. So interior scanning, this was definitely the main one that I was tasked with here at WSB, and where this technology is going and how we can use that. Public engagement obviously being a main one, and we'll go into some examples here as to how this can be used for public engagement, but even some rudimentary asset management. And an example I'll show here shortly of a water treatment plant and how they're using some of these ways to manage their assets and have links of PDFs to what they want to see. So with that, I'm going to actually just get right into our demonstration. One thing to note with these demonstrations is I'm using programs obviously to show that visually, but none of these programs are the end-all be-all programs that you can use. There's a lot of programs out there that can consume this information, that you can visualize this information with. So the first scan I'd like to show you, and this would be more of a public engagement side of things, is WSB's building down here in Rochester, which is where I'm based out of. And this is just, think of Google Street View, but in indoors, right? So if you wanted to show this to the public, if you wanted to show one of your buildings to the public or interiors to the public, this would be a great way to do it. And this was scanned with our, with that number 1 scanner I showed you. And so this is going to have very good imagery, but if you're looking to get an output of a point cloud in this probably isn't the scanner you're going to want. Now, the nice thing with that second scanner that I showed you, you're going to get more accurate point clouds out of that, as well as imagery. So if you're looking to kind of do both the best of both worlds, that's the scanner you're going to want to use. And so this would just be the walkthrough view that we can get with these scans for reality capture. And then just to show you also another walkthrough, as well as what you can do a little bit with asset management in these walkthroughs. So these are some masks for whatever, in case of emergencies. And if you look at the mask here, we're going to have a link to the asset of the PDF, hopefully. Let's see if one of these works. I'll link both of them. Here we go. So this is the actual unit that's inside of these cases. It's a PDF of the user manual. And if I open this, it's also going to open up a separate tab with a larger user manual here for viewing purposes. Maybe. Let's hope it works. And so here's the PDF. And now you can kind of use your imagination. Hey, I can link anything that's a PDF to anything that you want within your facility. So this is a great use case for, minimal asset management, as well as just to increase the technological workflow for your staff. So that is kind of the basic of reality capture that we can do, especially with interior scanning. Now, if you want to take it the step further, and one of the things that we've done also at WSB is, hey, that's cool and everything, and there's a lot of use cases for that, but we want to be able to plan off of these scans for the future, not necessarily exterior, which we'll get to, but the interior scans. And so we did take it that step further at WSB, and we used the leading edge in modeling, which is Autodesk's Revit. And so here is a model that I created out of the scan that we did. I did just take the roof off for the viewing, for this viewing, just so you can see the interior actual model you used. And these are the RVT file types. So these are going to be used in any program that can consume that file type. And what it looks like and what we get out of these point clouds and how we model off of these. And I can kind of also show you the difference in the cost of the scanners, since this was scanned with the cheapest of the 3 scanners I showed you. If we zoom in here, so this is a wall that's actually been modeled. If I quick take that out, you're able to see the outline of the point cloud. And so we're using this point cloud to actually model how the building is realistically in the real world. So we have as-built. Sometimes those can be a little bit off from what the actual building was built. And for planning purposes, for remodeling or for adding on, that can be very important, as well as archiving of your building, how it stands. And so as I was saying earlier, since this was scanned with our cheaper scanning unit, you can kind of see in the corner here, we have what we like to call potato chipping. And so if you use one of those more expensive scanners or the higher end scanners, you're going to get more, tighter corners. And maybe in this instance, it's not important for this demonstration, but that can be important for a lot of instances to get that, precise accuracy of centimeter to millimeter accuracy on that. So that is definitely going to be a difference. And I'll just put that wall back there. So that at WSB is what we've been doing with the interior scanning. So I did see that we did have a question on there. Kristen, did you see that question?
Yeah, yep. So the question is, what would an Autodesk workflow look like?
Well, ironically, we kind of just went through the Autodesk workflow. So I'll touch on that briefly, but I'll actually expand on that a little bit. So the Autodesk workflow is going to be using, depending on the scanner you decide, using probably the proprietary programs that come with that scanner to at least do the post-processing of the point cloud. Most, if not all of these programs after the post-processing are able to export into file types. The 3 file types that are important would be LAS, E57s, and PTS files, and then those can be consumed by multiple programs. So in the Autodesk sense, Autodesk has a point cloud managing program called Recap, and then that can be consumed in Revit to model off of if you want, or you can just keep it in Recap for visualization purposes. But those same file types can be consumed by Bentley. As a GIS specialist, our GIS programs can consume those file types. So really the sky's the limit. And also I do see the software kind of, at least at the moment, being the limiting factor. These scanners are collecting so much data that the software almost isn't quite up to par with being able to handle some of this data depending on how big the data sets are. So that's definitely something we're going to see moving forward. I think is that it for questions right now, Kristen?
Yep,
Okay,
for now.
all right, we'll keep the rest for the end then. So exterior scanning, and I'm going to talk on two of these and then give a quick demonstration on one of them. So the first one, as we can see here, is a surface. Now this one specifically is an image of a surface that we scanned with the SX10, which was that third unit. So this is going to actually have coordinate systems in it. You can see that it's actually a surface as well as a mesh. So this one specifically is important because they wanted to manage their stockpiling over time, because that's what's going to change. Now that's where reality capture really is going to save you money, because you're never going to be able to get a a LiDAR flight from an actual airplane frequently, right? So if you want to see the changes over time, reality capture is definitely key. Now this one was shot with a ground unit, but we can also do the same thing with drones, and that's why that drone is under the umbrella of reality capture. And it's definitely going to be way more cost effective for projects to monitor these surfaces over time as well. And then once we do that, and once we collect that data, the surfaces can be brought into AutoCAD, Bentley, and then they can be planned on based off of those surfaces. The second image down here is MSE walls. So these are on the side of highways. And what we're doing with this and how accurate, especially that higher end unit is, it's millimeter accuracy. So we're actually monitoring the movement of MSE walls over time. So these MSE walls will go scan every 2 months, bring them in, create a surface out of them, and compare the surfaces to see how much movement and how they need to plan for the future of, okay, these are moving a lot, we need to plan now, or these aren't moving much, we're just going to keep monitoring that over time. So that's another example of how we're using reality capture in the field outside. And then third, and probably my favorite, is going to be the exterior shell scanning. So this once again was shot with the SX10, which was that higher end unit. The client for this wanted an exterior scan of their building so they could compare that to some of their as-builts to make sure everything lines up the way they expected it for future planning and expansion. And once again, this came from a Trimble unit, so we're using Trimble Business Center, which is not the end-all be-all for managing point clouds here. But this is a point cloud of a building scan that can be brought in. And now I've cleaned this up quite a bit, and if I want to bring in some of the more parts of this point cloud, we can add vegetation and the ground to this point cloud. So there's definitely a lot more noise with the initial scan, and there's some cost of post processing on this for depending on what you want to use it for. But that's another way that we can use the exterior scanner for building exteriors and whatnot. And then finally, one of the newer technologies we've been working on at WSB here, and this is kind of what we've been using that middle scanner for, is manhole scanning. And this can be important mainly just for asset management, and especially with the times we're in right now. And this isn't going to go away. This isn't going to go away once the coronavirus is gone. But being able to bring this data into the office to both do inspections as well as measurements, as well as just archiving of your assets, is very important. And these manholes specifically, we're scanning for a client. We're going out there collecting the manholes that they specifically want scanned, so they can both archive, plan, and model off of for future use as well as current use. And I can kind of show you what these point clouds look like in Autodesk's recap program here. So this is one of the scans. This is one of the point clouds of a manhole that we scanned. And if I want to quick cut this in half, create the limit box here. Just want to cut the point cloud in half. And I can just show you how to do quick measurement on, hey, what's the actual width of this point cloud? And because we're using one of the higher end units, you can really trust the measurements on this. So I'm gonna go in here, quick take a measurement from wall to wall. And so, 5.9 feet is roughly the diameter of this, the manhole. I probably could have spent a little more time to get a more accurate measurement on that, but that's what other cities are using reality capture right now to manage their underground assets. And on top of just managing the assets, this increases safety, right? We're not sending our office workers into the field to go in a manhole, 5 times because we need to get measurements. We just need to send one person with a scanner out there once, that they don't even need to get in the manhole, to get this scan. And then once it's in the digital world, you can bring it back to the office and collaborate with each other, take your measurements off of it. And you only need to do that once. Now, obviously, if something were to change with this manhole, if maybe it took damage, you would need to rescan that. And that's just because things have changed since when you last scanned it. But as a whole, this is what you can definitely use to manage your underground assets. And then finally, the benefits of reality capture. So what I like to have come up with is safety, and we just kind of covered that. You know, you're not going in the field nearly as much, and anytime you're in the field, there's a possible safety risk. You're going in the field once, maybe twice, depending on if things have changed, and then bringing this back into the office. And that increases time efficiency, and bringing this data back into the office definitely increases collaboration between each other. You guys are both looking at the same scan or the same digital data that you are both collaborating on. Cost reduction, and this comes with the fact of, similar to safety and time efficiency, you're not having staff go in the field and take measurements, 5, 10, 15 times a project. And then finally, and probably the most obvious out of these, is asset management. Just managing your existing assets and as how they lie in the world right now, and that's what we're using reality capture for. So I did see a couple more questions pop up, and that's all I have for this. So I'll leave this here for my contact information. And Kristen, did you see those questions?
Yeah, yep. One of them was, how do you see this service benefiting projects in the future?
Right, so we've really had a big jump in how we're using this at WSB right now from just last year. And last year was really when I was digging into how can we use this in our service areas. And how I see this benefiting projects in the future, both interior and exterior, is definitely monitoring. That's going to be the biggest one, like before, during, and after projects. Because this is cost effective, it's not even a full survey crew, right? One person can go out and manage these and scan these, and then bring them back, post-process them, and then we have this data. So I see that being a big one, is before, during, and after, both for liability reasons as well as just for archival reasons. And then more so that I see this affecting asset management collecting for interior use. I think we're in the infancy of this right now, and it's going to take off where we can actually start collecting assets. With one scan, we can collect all the assets of an interior building. Just because I'm a GIS specialist, I'll say in the GIS platform, but it can also be used in other platforms. So that's how I see this ramping up. And I think really the sky's the limit. If you just want to see how things are right now, this is a great way to do it.
It looks like our final question is, what are the uses or applications for this technology?
Right, and we definitely went over quite a few of the uses, and I kind of go back to the last comment I just made from the last question, is the sky's the limit, right? So anything you can imagine. The biggest one that I can see right now is if you're planning on a remodel, both either interior or exterior of a building, and you want to save money. And the best part of using the Revit model to model these buildings from the interiors, you can hand that Revit model off to an architect that can then help you create plans for multiple options for plans that you want for your building. And then also just the surface scanning has been a big one that we've been using here at WSB to plan for where buildings are going to go, or what we need to change in the surface in order to make it safe for a building not to move, or for grading purposes on a surface. And that's really where I see this going. I'm really excited that we're starting to get deeper into the weeds with this at WSB, and there's going to be more coming out with this in the near future. So I'm excited for that too.
Great. Well, that's I think all that we have for today. Thanks so much, everyone, and have a great day.
Yeah, thanks everyone.